Hello, wonderful people. Here we are, section 37.2, Faraday's Law. Oops, click. Okay, here it is written in English. Faraday's law states that the induced voltage in a coil is proportional to the product of three things: the number of loops times the cross-sectional area of each loop, smaller is better, times the rate at which the magnetic field changes within those loops. Faraday's law describes the relationship. That's the same thing in yet another sentence. So I'll just read it. Faraday's law describes the relationship between induced voltage and rate of change of a magnetic field. The induced voltage in a coil is proportional to the product of the number of loops, the cross-sectional area of each loop, and the rate at which the magnetic field changes within those loops. Here it is in an equation. E is the voltage. E is the value of voltage induced. The old name for voltage was electromotive force. Do you remember that, EMF? So that's why we still use E. The change in time for the experiment is dt, that's on the bottom, and time is measured in seconds. And finally, there's the meat of it all. Last is dB, which stands for the change in magnetic flux. And B is magnetic flux, and that's measured in Teslas. So you may have heard of that guy named Tesla. He's just another scientist that we've named a unit after. And this tells us what is Tesla, which is the unit for how strong a magnetic field is. Magnetic flux is what we call it. So we've talked about force fields before. How strong is the field that carries the magnetic force? Well, that's measured in Teslas. Just so you know, a 1 Tesla magnet is really strong, like maybe enough to pick up a car off the ground. Maybe not quite that much, but definitely 1 Tesla coil could move hundreds, maybe 1,000 or 2,000 pounds. Really strong. So we normally measure things in milliteslas or microteslas if it's pretty big. Skip that. Skip that. All right, think. If you push a magnet into a coil connected to a resistor, so the coil is going to put current through the resistor because it's making the voltage, and the current will flow because it's going through the resistor. You'll feel a resistance to your push. For the same pushing speed, why is this resistance greater in a coil with more loops? Talked about this earlier. More work is required because more voltage is induced, producing more current in the resistor and more energy transfer. When the magnetic fields of two magnets overlap, the two magnets are either forced together or forced apart. When one of the fields is induced by motion of the other, the polarity of the fields are always such that the force of such as to force the magnets apart. Right. Inducing more current and more coils increases the induced magnetic field, and that therefore increases the resistive force. So, what does Faraday's law state? That's what you need to come out of this with.